Assalamu alaikum student. Today we are going to study modern periodic table. Think about how modern periodic table was arranged. Today our objectives are: you may understand arrangement of modern periodic table, understand salient features, and understand the terms about blocks, period, and groups in detail. In 1913, Moseley was working on X-ray produced by different elements. He observed that instead of atomic mass, atomic number is a more fundamental property of elements. On the basis of Moseley's work, periodic law was amended. What is periodic law, or what is modern periodic law? According to modern periodic law, properties of elements are periodic function of their atomic numbers. What is the importance of atomic number? As you already know that atomic mass is represented by A and atomic number is represented by Z. Atomic mass is the total number of proton and neutron inside the nucleus, while atomic number is equal to the number of proton or number of electrons. So, atomic number is fundamental property of an element. Atomic number of each element is fixed. Even isotopes of an element have same atomic number. It increases regularly by the value of 1 from element to element. No two elements have same atomic number. In a neutral atom, atomic number is equal to the number of electrons. And lastly, atomic number provides basis of electronic configuration, which is the basis of chemical properties. On these observations, modern periodic table was arranged. It is based upon the arrangement of elements according to increasing atomic numbers instead of increasing atomic mass. In modern periodic table, elements are arranged according to the increasing atomic number, from left to right in horizontal rows, which are called period, and properties of elements were found repeating after regular intervals such that elements of similar properties and similar electronic configuration are placed in the same group. What do you mean by regular intervals? After 8 elements, when Z is equal to 11, the element which has atomic number 11 has similar properties as the element which has atomic number equal to 3. After 18 elements, the element which has atomic number 37 has similar properties as element of atomic number 19. Periods are cut in rows of 8, 18 and 32 elements and are placed one above other so that table of vertical and horizontal rows was obtained. What are the salient features of the periodic table? Number 1. In periodic table, elements are arranged according to increasing atomic number in horizontal rows, like lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Their atomic number are 3, 4, 5, 6, 7, 8, 9, 10 respectively. Number 2 point. This table consists of 7 horizontal rows called period. Just like period 1, which contain 2 elements, period 2 and 3, which contain 8 elements, period 4 and 5, which contain 18 elements, period 6 having 32, and period 7, which is still incomplete. Third point. Elements of period show different properties due to different electronic configuration. Number of period indicate total number of shells. For example, hydrogen and helium are located in the period 1 and first period indicate K shell, and their electronic configuration for hydrogen is 1s1 and for helium is 1s2. As their electronic configuration is different, so they show different chemical properties. Number 4. There are 18 vertical columns numbered from 1 to 18 from left to right, which are called groups. Number 5 point. The elements of a group show similar chemical properties due to same electronic configuration. For example, look at the elements of group 1. It contains hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium. Their electronic configuration can be written or understood as according to their period number and number of electrons present in the valence shell as well as their place in the block. Group 1 belongs to the S block and electronic configuration of hydrogen is 1s1 because group 1 show that this group has only one electron in its valence shell. Similarly, lithium show electronic configuration 2s1, sodium show electronic configuration 3s1, potassium has 4s1, rubidium 5s1, cesium 6s1, and francium 7s1. Elements are classified into blocks S, P, D, and F according to the types of subshell which gets last valence electron. Let us try to understand about blocks in the periodic table. On the basis of completion of a particular subshell, elements with similar subshell electronic configurations are arranged in specific blocks. For example, group 1 and group 2. They are placed in S block according to their specific electronic configuration. They are known as normal elements. From group 13 to 18, elements are known as P block elements. These are also called normal elements. From group 3 to 12, elements are known as D block elements. These are also called transition elements. These contain 10 elements in each period. There are two rows below the periodic table which are called inner transition elements. These are placed in F block. These contain 14 elements in two series, lanthanide and actinide. Lanthanide and actinides are separated from the period 6 and 7 respectively due to their radioactive behavior. Now try to understand about period. As you know that horizontal rows in periodic table are known as periods. Period number indicate number of shells. Elements are fixed in a period due to fixed number of electrons accommodated in shell. First period is known as short period. It contains only two elements, hydrogen and helium. Second period and third period are known as normal periods. They contain only 8 elements each from atomic number 3 to 10 in second period and atomic number 11 to 18 in third period. Second period has lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. While third period contains 8 elements, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine and argon. 4 and 5. Both periods are known as long period. Both have 18 elements each. Fourth period starts from atomic number 19 to 36 and fifth period starts from atomic number 37 to 54. Sixth period contains 32 elements. It starts from atomic number 55 and ends at atomic number 86. After atomic number 57, 14 elements are separated from this period below the periodic table in a separate series known as lanthanide. Seventh period is known as incomplete period. Till now, it also contained 32 elements, and after atomic number 89, a series of 14 elements is separated from this period and placed below the lanthanide known as actinide. Both these series are separated from periodic table to save the place, and also these are radioactive elements in nature. Groups. As you know that vertical column in a periodic table are known as groups. So groups contain similar electronic configuration. Let us see the periodic table. First group is known as alkali metal, as they have one electron in their valence shell, so their electronic configuration is ns1. Second group is known as alkaline earth metal. They have two electrons in their valence shell, so their electronic configuration is ns2. Group 13 is known as boron family. They have 3 electrons in their valence shell, so their electronic configuration is ns2 and np1. Group 14 is known as carbon family. They have 4 electrons in their valence shell and their electronic configuration is ns2 np2. Group 15 is known as nitrogen family. They have 5 electrons in their valence shell and their electronic configuration is ns2 np3. Group 16 is known as oxygen family, or it is also known as chalogen family. They have 6 electrons in their valence shell, so their electronic configuration is ns2 and np4. Group 17. Group 17 is known as halogen family. They have 7 electrons in their valence shell and their electronic configuration is ns2 and np5. Similarly, group 18. These are known as noble gases. They have 8 electrons. Their octet is complete, so their electronic configuration is ns2 and np6. Today we have studied arrangement of modern periodic table, its salient features. We have studied blocks, period and groups in detail. Hope you have understood well. Allah Hafiz.